Hi all. Basically, I want to go through an example of how to sketch a sine or cosine graph with transformations. In this case, we have a sine graph with some transformations, and we're trying to graph it from minus pi to pi. This will be a bit of a longer video than the one before, but basically I just want to go through an example of how we go about this. Now, regardless of the domain, what I'd like to do when I have these questions is just go through basically the basic sort of format. So in this case, we have a sine graph, and there's no inversion. It's just a regular sort of situation. So I like to look at what a regular sine graph looks like. So this is y equals sine x. And so what we can see here, and I'm going to, in this case, choose p as period, is that basically at here we have one full period, here's half a period, here's a quarter of a period, and here's 3/4 of a period. And I'm going to label these values actually. So at this middle point here, that's our mid value. Up here, that's our peak, or our max actually. Maybe I'll change that to max. Okay. And then down here we have our min. And so in other words, what we notice is that at the very start, and so I'm just going to write that as a 0 here. At the very start, we're at the midpoint. After a quarter of a period, we're at the maximum value. At half a period, we're at the middle value here. At 3/4 of the period, we're at the minimum, and then we're back to the mid value after one period. And so this is your standard sort of sine graph. That's coming from starting from the point 0, 0. Now what we want to do is basically consider the transformations that have occurred. And the main one I'm going to look at first is just the translations. So what we can see here is with this graph, basically this pi and 4, this plus pi and 4, suggests that it's going to be moved, the origin here, that's going to be moved to minus pi and 4, and is pushed up 1. So in other words, that origin point is now, let's say here. And so this is minus pi and 4, and that is 1, like so. And because this midline here has now been raised by 1, and we can always tell from this the vertical translation, then basically what's going to happen is if I draw a line across, maybe I'll bring that down a bit, like that. So this is our new midline. And so something we want to do for this graph is try to figure out what the max and the min would be, because it's going to be useful for us to basically look through where this graph is going to be moving between. And so for this graph here, I'm just going to get all the information. Basically, our mid is at y equals 1. Our max is going to be, actually we'll do amplitude first. So the amplitude is going to be 2, because that's the number that's in front of here, that coefficient. And so what that means is that our maximum is going to be 1 plus 2, which is going to be 3. And then our minimum, that's going to be 1 minus 2, and that's going to be minus 1. And so if I draw another line across, so down here, y equals minus 1, and y equals 3. I'll bring this up a bit so it's a bit more to scale. But essentially, we're going to be moving between those values for the sine graph. Now, something that we want to do then is just relate this back to what our regular sine graph is. Essentially, let's take a look at this idea that every quarter of a period, we're going to be at some known value. We're either going to be at the mid value, the max, or the min. And so we just want to figure out what the period for our graph here is going to be. So the period for this graph is going to be, because it's a sine or cos graph, it's going to be 2 pi divided by this coefficient here. In this case, that's 2. And so that's going to be pi. Which means that in this case, every pi on 4, every period divided by 4, is going to be a known value that we have, starting from that start point, which in this case is this point here. So let's maybe start with that. So we know that at this point here, at minus pi on 4, 1, that we're starting at that origin. So it's essentially just we start at that point there. Then after that, at pi on 4 after, because it's period on 4, we're going to be at the max value. So pi on 4 after, that's going to be, from minus pi on 4 to pi on 4 after, that's going to be at 0. So it's going to take us up to here. Then pi on 4 after that, that's going to be, we're going to be back to 0, or back to 1 actually, we're going back to the midpoint. And then after that, another pi on 4 after, so maybe I'll just write all these different ones. So then another pi on 4 after, which is going to take us to pi on 2, that's going to be down at the minimum. Another pi on 4 after that, that's going to take us back to the 0, or the midpoint, I mean. And then finally, we get to pi, and we're at the maximum. And so basically this process, we just repeat it until we reach the endpoint that we want. And so what I've done here is I've gone from the center to the right, and so that's what I'm doing here, and I'm just going to basically fill in those gaps. And then next, I'm going to go left. So I'm going to basically go all the way to minus pi. And so what we can see here is that from minus pi on 4, if we go a quarter of a period to the left, that's going to take us to minus pi on 2. And we expect that that will be a minimum value here. another pi and 4 across, so that's going to take us to over here. And then another pi and 4 to the left, that's going to take us to the maximum, which is up here. And so essentially then we have our entire graph, we just have to fill it in. The only things as well is that we don't have the x-intercepts, but we can do that afterwards. So essentially I'm just going to make this into a smooth sort of curve, as smooth as I can. Yep. Not too happy with that one. Let's try that again. Okay. And essentially that's it in terms of your graph. The only thing that we're really missing is we don't have our axis labeled. And so then I'm going to label this one here. That's an easy one that we can do. So we see that is going to be 0, and we have a max of 3. So we're going to get 0, 3 here. And then now the harder part is looking for these x-intercepts. And this actually would take up the majority of our time here. Essentially what we're going to do is we want to know when the solutions for when y equals 0. So what we do is we solve for y equals 0, which in this equation is sine plus 1. If I rearrange this, then what we're going to do is basically we're solving this equation here from, where are we going from? We're going from minus pi to pi. Now there's a bit of algebra here that basically uses the approach from before for solving trig equations. And then finally, once we have those, we have our intercepts there. I'm going to skip that for the sake of time, but that would be the approach that you'd use. After that, you can label those things there. The main thing that I wanted to show you is so you can get an idea of how to plot the shape and things of that nature. Okay. So I'll be creating a more complex example, but let me know if you have any questions.